Welcome back, mathematicians. This time we're going to talk about Descartes' Rule of Signs. So, for Descartes' Rule of Signs, what we're going to do is we're going to look at the sign changes for each term in our polynomial. So, in this example, my first term here is a positive, so positive. This one's a negative. I'm just looking at just the signs, right? This one's also a negative. This one's a positive. This one's also a positive, okay? So, and in fact, what I want to do is look at just the change in signs. So right here, I go from a positive to a negative. So that's one, negative, negative, that's not one, negative to a positive, that's another one. So for this polynomial, I have, let's see, two possible positive, and I might have two, but I also might have, it's 2 or 0, right? Two of those roots could be complex, right? So they wouldn't be positive, I should say positive real roots, okay? So it's 2 or 0. And if we think about our complex conjugate, there's no way I can just have 2, 1, or 0, right? Because they come in pairs. So if I'm going to get rid of some possible roots, then it has to be either 2 or 4 or 6 or 8, because all the complex roots come in pairs. So it's 2 or 0 possible positive roots. And for the next one, so if I want to see if I have negative possible roots, what I'll do is I'll just plug in a negative x into my polynomial and see what happens, okay? And then again, I'm looking for changes in sign. And what we'll see here is I just plugged in a negative x for all of my x terms, right? And actually, here's a kind of rolled in pro tip. I don't have to change the signs of everything, right? If we think about it, right? All my, let's do this in green. All my positive signs, right? Or sorry, all my even signs. So things like x to the second, x to the fourth. If I plug in a negative x to the fourth, say, actually let's do second, x negative x to the second. Negative x times negative x, that's going to give me just x. So if this was a positive before, it stays positive. If it's a negative before, it stays negative. So just the even exponents don't have a change in signs, right? But our odd ones do. So let's try negative x to the third power, for example. That one will be negative x times negative x times negative x. That will have a change in sign. So if it was positive before, it's going to be negative after, okay? So let's take a look back at our example, and we'll apply that knowledge there. So this one again is odd, and it's going to be a change in signs. This one's odd, and these ones are both even, so they won't change. Okay, I'll catch you in a second. So again, my odd exponents had a change in signs, but my even ones did not. Okay, and then again, I'm going to look for a like my changes in signs. So this one from a negative to a negative, that's not one. This one from a negative to a positive, that is one. This one positive to positive, that's not one. Positive to positive, that is not one. That is not one either. So I have I have one possible negative root. Okay, so and again, I can't take anything away from that. So this is if we're using the rational root theorem, looking for possible x-intercepts, this is a good place to start. This one I might have 2, I might have 0 for positive real roots, but for negative real roots, I know I have one of them. At least, yeah, I have one of them. So I can look there to try to see if kind of cuts my possibilities in half. So that's good for us. All right, so that's it for this video. I will catch you on the next one.